let's just move to the next question. So, what will be your advice to a beginner? Like a beginner is expected to do a lots of things. Like he should be
Yeah.
doing online courses, he should be doing open source contribution, he should be writing blogs, he should be doing most other things. And so, what like do you have any priority list that you would suggest to a beginner? That okay, follow this, then this, something like that.
Right. So I think you have to always set a 6 months goal, then 1 year goal, always like that for what you want to, where you want to be. So I can give my own example, and I think also in this particular following this line of thought, I had written one article first that how I started, that I did not have much programming experience, so I thought that initially I will just learn a little bit of programming. So I always spend time on MOOCs. What I did not, do much time spent on is Kaggle or Hackathon. I did not do much. I'll come to that later. Is that why? But you can start with finding out good online resources. There are plenty available now, and just go with free resources like audit courses on Coursera or edX or Udacity or something like that. And you have to find particular things. Like for example, Udacity has all these paid programs which are nano degree, right? And nano degree you have to pay, but the courses are free actually. So all the good courses within the nano degree, at least the foundational course for nano degree are free. So if you want to learn, I'm just giving an example of AI, right? There is AI nano degree of Udacity, but there is AI course offered by Georgia Tech, which is free. And there are two courses of AI. One is by the Professor Norvik, Thurman and Norvik. That's a great course. And then there is another one, a little bit watered down from the Georgia Tech. And there also, Dr. Norvik talks about, in some lectures. So there are two, you can always find free courses if you just do not want to spend money on that. So take courses, and it's very important to take courses and watch videos because, and do not think, as I said earlier, is that do not think of this MOOCs as something which will go to your resume and as a certificate. Think there's as a learning resource. So take the exact same course, which is called machine learning or statistics for machine learning or something, for 3 different sources. You just take it, and then why it will give you different perspective, because different faculties are teaching, right? One could be a programmer teaching you, one could be an IBM fellow or something like that, and another person could be a faculty teaching the exact same thing, but they will come from 3 different angles. So the exact same concept will be explained to you from 3 different angles, and when you get hit by 3 different kind of explanation of the same topic, then what happens is that if you just watch one type of thing, then it fades from your mind very quickly, right? In 90% you'll be forgetting. But if you just get 3 different viewpoints, then you will be forced to, your brain will automatically form kind of connections, I would say, and then you will have a higher chance of retaining that thing. So explore all the free resources like videos and blogs and stuff like that as much as you can. And then the next step is basically take a simple use case problem from website on the topic that you want to learn. Say you want to start with data wrangling, then you take a use case problem from like a pandas or NumPy or something like that, and then how to wrangle it. Just focus on that for not time. So every month you can take one new topic and that you want to learn, and then try to get some examples and then work out that example yourself. But always remember, try to add some value to it. That means do not just practice and think that you have learned. So add some value, some twist to it. So even if nothing, just do a programming to generate some more synthetic data out of it, and then apply the technique with the new data, right? Do not take the same data that they are using, right? Or just take complete different type of data set, and then see whether the same topics, same algorithms is working in a similar fashion or the same performance with the different data set or not. If not, then basically you got a point, you think about it a little bit, and then you may learn something new out of it, right? So that way, so I spent a lot of time on adding value, and then I wrote articles about them. So that's why I probably did not have much time on working on a very streamlined problem like Kaggle and hackathons. They give you a clean data set already and then do it. Because I thought that learning new topics and adding value to them is more important. That's my style of learning versus just doing a lot of things with a given data set kind of thing. So that's why I chose that part. But it's up to you if you want to get experience in competitive programming and then hackathon kind of time pressure bound programming. You are welcome to do it. I have, my style of learning has been a little bit different. That basically take a topic, explore a use case, and spend some time, add some value, write a blog about it maybe, and then see whether how to add more bells and whistles to it. So take everything from data wrangling to modeling to visualization to dashboarding to say production, like write a small flask routine to serve it on a personal website or something like that. Then the whole code, put it in a Docker and keep it somewhere so that other people can use it. Now you can know that you are a full stack kind of thing. You can do whole thing, even if it's a small thing, even if it's a small linear regression, but you know all the steps kind of thing. So that gives you a better. You can go depth or you can go vertically. So both are important, but you can go depth later, because unless you have a lot of experience already, demonstrated experience, people will not pay much value on your depth. So initially for junior data scientists, actually it's better to go on spread, like a horizontal spread, and learn the full stack actually.
Yes, makes sense. So I have 3 points in that what you have said. So one thing that you said, that taking courses, same course from 3 faculties. So one is like some university, like say MIT, other one is from IBM. So what you will have here is that you'll be getting academic knowledge as well as industry application of that one.
Sure.
So just like learning something, and also how to apply that also you will learn. And the point that you have also already mentioned, that learning the same thing with different perspectives, getting into it, that will make a more strong neuron connection. So that makes sense. Yes. Other than that, like the one point that hit me, what was never do a course just for the resume, like just for making a bullet point on resume. So that does not solve a use case, like that does not solve a problem. So if I had done 10 courses and I don't know, or I had just done just for pointing it in my resume, that does not make sense. My interviewer will ask me that, okay, you have done this, let me discuss about like RNN. Okay, I had done courses on, let's say, NLP and all those things I had mentioned, and he just asked me, okay, explain me the functioning of RNN, and I'll be like stuck, I don't know. Okay, then that does not solve. That might lead you to an interview, but at the interview you will always fail if you don't have the proper knowledge. I really appreciate that point. One point that I wanted to get into depth of that. So you are a big supporter of open source contribution, I guess. So I had one point that you, like, at the end you pointed out that you should be knowing end to end, like from, even if it's a very small thing, it doesn't matter if you know end to end. So that last week I had posted one post on LinkedIn that was like, what separates a project, like a normal and ordinary project, from an extraordinary project. So there are many, like some said business perspective and on all of those things, that they are very important. But this point that you said, right, this is also very important. So if you know end to end, like from the beginning, from the algorithm level, from the data level, and then deploying it on the production server, so that makes a like good combination. So that is very good. One more point that I have, that I want to get into depth of, that is open source contribution. So what is the approach one should go for? Like let's say there is Panda's open project is there. Should I go on contributing on those, or should I make my own projects first? Like what should be the approach?
Yeah, this is a good question in the sense that there is a lot of people think that there is a lot of entry to barrier there because if you try to write your own code, it may not be up to the mark of this already existing open source project, and that is true. When you are starting out, you do not know all the kind of software engineering, particularly if you're not coming from software engineering background. Then, like for me, for example, I do not come, so I did not know about these things, simple concept like unit tests, right? I never know because I'm not a software engineer, right? So I started doing the open source in my own kind of projects, hobby projects, and then there has to be something different. For example, one project that everybody has notebooks and Jupyter notebooks about standard machine learning algorithm, but I said, okay, there is this thing called IPy widgets, or where you can do some slider or some drop down. And then when I'm watching a video of a machine learning, I love to watch if somebody is like changing the model of the order of the machine learning by dragging a slider, right? Kind of interactivity. So I wrote some notebooks about it and put it there, and that people have copied that thing long time. And so you can think about what is needed if you look around what you need, and you can contribute there. That way you can come up with your own open source. I'll give you a very simple example. When I was starting learning SQL language or SQL, right? Then I found that there are many good database or dataset free open datasets for machine learning, but there is not good database for simple like SQL practice, because it's like a transactional data or something like that. So I thought I will take a open source package, and then I will generate the synthetic data out of that database. So I created a whole open source package just based upon that, taking some other open source package and basically creating a database, and that got very popular. And there are some people even in Silicon Valley, they got interested in that. So that way you can learn, even if it does not have all the bells and whistles of a complete project, but you have put something. So again, go through the end-to-end experience there, creating a notebook, then creating functions, then creating classes, which is the object-oriented. You have to do all those things to launch it as a program, and then go through writing a document about it, and then putting that on a PyPy or R or some kind of server where people can just use your package by downloading pip install your package kind of thing. So that is an experience yourself. Even if you write two functions just to calculate roots of a quadratic equation, right? As simple as function. You create the classes, create the methods, and then put that thing as a package on the PyPy server, and then you can say that okay, I have gone through the whole experience. So that's one way. Other thing that basically you can sometimes find out bugs and issues on great packages like TensorFlow, NumPy, Pandas. I just found out some issues on Pandas. I reported that, created an issue, and then they said that they kind of explained to me what is going on. They understood that there is some limitation. So I had some talk, and then this gives you experience of interacting with the active developer community. So you can do a lot of things on the bugs and resources issues also. Or sometimes you can extend the function of that. So for example, one example is that there is a book of artificial intelligence modern approach by Stuart Russell and Norvig, right? And then there is a community which builds all the example of that book, and they have excellent example of reinforcement learning. So they have a limited kind of reinforcement learning environment setup, and it takes a list, Python list, and it creates a environment, reinforcement learning environment out of it. But then I thought that is limited. So if it is only a list of lists kind of data structure, then can I not make a simple program which will do an arbitrary kind of big data set of that or environment? So I proposed that idea, and they liked it. So I give them the code. I opened an issue. They kind of integrated it. So this gives you experience how to work with a community. Just open an issue and create your own code, fork it, and then contribute it. So it's very simple idea. Just work with the data structure of a Python, but it gives you extend the functionality of existing kind of code that is already there in GitHub and popular. So find out all these things. There are 3-4 different things I talked about, and I think you will get a hang of it.
Sure, makes sense. So it's a very good way that you have explained that thing. So it's basically adding your flavor. So that I basically love that point. So let's say, and please correct me if I'm getting something wrong here. So as you said, so what I feel, if someone has done a project, okay, let's say end-to-end, whatever, like a simple project, simple concept, but he has done end-to-end. And other guy, he has done no projects, but he has done some courses which are on that particular flow. So I think the other guy, the guy who has done projects, I feel that guy is more interested. It might be my bias or something like that, but I feel that the guy who has done the projects end to end, who has tried his got his hand dirty, I will feel that this guy is more interested in this particular thing as compared to the other guy who has just done the courses, right? Please correct me if I'm wrong.
That's right. I mean, of course, it ultimately boils down to saying that what kind of, if you're interviewing to such person for a job role, what exactly is the job role? Some of the job role could be, okay, just read papers and come up with new algorithms. So there you need very theoretical kind of bent of mind who can explore ideas. But also remember, he also has to test the ideas, but he's not expected that kind of person to do a production level coding or something like that. So that's a very specific role. Those roles are not very hard to come by, but most of the things Even if you do not need a person to do all the things in a data science pipeline or team, and not one, it's a teamwork always. So, but it's about the translation, and that's extremely important. How do you, if you are a good translator of, in the sense that you understand or you speak the language of the programmer, at the end, even the marketing person who is sitting with the customers and coming back from pain points. And this is not, I'm not telling this thing from data science. I'm not a data scientist in my job description. I'm a semiconductor engineer and a research scientist, let's say. But although my job is not directly customer facing, but I love to go to customers and translate their pain points, their problems into the technologies that I should develop. So it's a complex process, because at the end, one end you have very mundane everyday use case versus another. On the other hand, you have a technology which is related to fundamental physics or something like that. But then you have to make the link. Over the years, you get the experience. And same thing for the data science here. Basically, one end you have like increase my profit, right, or decrease my cost. That's the problem description they are giving you. And on the other hand, other end of the spectrum, you have how to change the learning rate. What is the relation? What is the function between the learning rate of gradient descent algorithm with the profit, right? You have to make that link. So if you speak only the language of all the things, even if you're not in the same depth, but you know what impacts the profit. Is it they are hiring? Is it they're renting an AWS service or something like that? How much they're paying versus they have an on-prem kind of thing? What is their model, business model? Then comes to how their production codes are written versus then how the algorithms are translated in production. So you're backtracking down to your field. Then you can make a connection and you say, if I turn this knob, then this is affecting my customer kind of acceptance, right? So this is the end-to-end kind of thing, always in every industry, not only data science. If you are working in biology, medicine, finance, banking, anything, you have very technical things which if you try to explain to a customer, they will not understand. They understand certain things, right? But it's your job to make it, and the better you kind of grow yourself in that role, you're more valuable to your organization.
Perfect. Yeah. So I'd like to share my experience also. So currently I'm working in a startup. So I'm involved from a basic, like selecting the data infrastructure, modeling, and then finally putting into the production. And I'm really loving it. So I'm getting the flavor of all. And I think one interview before, I had one interview with Ankit Rathi, that he's on LinkedIn also. So he gave me a very good analogy for that. Like there should be a T-shaped a person. So you should be like in your technical domain, whatever you have, that should be a T, but you should also have a bed of all the things.
Depth and go, vertical. Yes, very good. Yes.
Yeah. So that makes sense. Okay.